Okay, so today we're going to talk about trig identities. We're going to think about ways that we can identify or maybe swap things out. Now, if you know who I am, my name is Bergman, my name is Sharon, I'm a mom, I'm a daughter, I'm a friend. I have a lot of identities to who I am. And maybe to my mom, I would be called Daughter Sharon, but to my kids, I would be Mother Sharon. Aren't I the same person? And so that's the way we have to think about these identities. What is exactly the same as sine? Well, sine, as we know, is the reciprocal of cosecant. So sine of theta is also exactly the same as cosine 1 over cosine of theta. Sorry, cosecant. Cosine is the same as 1 over the secant of theta. Just like cosecant is the same as 1 over sine of theta, and secant is the same as 1 over cosine of theta. These all mean the same thing. Now, tangent is 1 over cotangent of theta, as you would think, but tangent also and cotangent also have a different meaning. Sorry, I'm going to rewrite this. 1 over the tangent of theta. Remember that sine is your y value and cosine is your x value. Tangent is y over x. And if that's the case, tangent is also the same as sine over cosine. Cotangent then is the same as x over y or cosine over sine. So again, tangent and cotangent have a different or two identities that you can use. So those should seem pretty easy to you. The next one is when we talk about squares. So notice there's no squaring in these. These are kind of like they're linear, okay? But once we start getting into the squared, we're going to look at sine squared of x plus cosine squared of x. That equals 1. Everything we're going to say from here is built off of this identity. So if I were to solve for sine squared of x, I would have to subtract cosine from both sides. Or if I were to solve for cosine squared of x, I would have to subtract sine squared from both sides. So this is just moving that around. Okay, the next one I want you to know, so we have sine squared, we have cosine squared. Let's look at cosecant squared. Cosecant squared is equal to cotangent squared of x. Cotangent squared of x then is equal to cosecant squared of x minus 1. Again, we're just rearranging the order. The last one we're going to look at then is secant, and that is tied with the tangent squared. And tangent squared of x is connected to the secant squared of x. Now, I would have these written down somewhere because these are more identities that we can use to simplify things out. So, how are we going to use these, or what are we going to use these for? Well, if I asked you to simplify tangent of theta times cosine of theta, you always a good general rule is to get things in terms of sine and cosine if you can. So the tangent of theta, I also know can be written as 1 over cotangent. But is cotangent going to help me with cosine? They're not the same. I also know that the tangent of theta can be written as sine over cosine. So I am going to rewrite tangent of theta as sine of theta over cosine of theta. And now when I multiply that by the cosine of theta, anything on the top can cancel with anything from the bottom, and I'm left with sine of theta. So that's simplifying that out. Okay? So So let's try a more complex one. 1 plus the tangent squared of x divided by the cosine squared of x times the tangent squared of x. Again, your general rule, if you can, is to get everything in terms of sine and cosine, or sine squared and cosine squared. So if I look over here, 1 plus the tangent squared of x is on my list. And if I can, I always want to swap those identities out. So what is that the same as? That's the same as the secant squared of x over the cosine squared of x times the tangent squared of x. So I took care of one thing. Now it's just a matter of seeing what would come next. I know the easiest, or the next one that's easiest for me to see, is swapping out the tangent. So this stays the same, but the tangent is sine over cosine. If it's squared, it would be sine squared over cosine squared. Now, there still isn't really anything that I can swap out. However, I do know that the secant can be rewritten as 1 over cosine. So 1 over cosine squared times cosine squared. Okay, so secant squared of x is the same as 1 over cosine squared of x. Then I have this cosine that's on the bottom. I'm going to rewrite it as cosine squared of x again. And then I have my sine squared over cosine squared. Now remember, our goal is to get everything in terms of sine and cosine, which I did. So now if we're going to simplify this, what do I have on the top? Sine squared of x. What do I have on the bottom? This is like saying x squared times x squared times x squared, which would be cosine to the 6th power. I know that looks funny, but that is as simplified as it gets. Okay, let's try this one. All right. Again, your goal is to turn everything into sine or cosine. So let's look at cotangent. Cotangent can be written as cosine over sine. Sine is already done. This is like having it over 1. Cosine is already done. That's like having it over 1. And secant, we know, is also the same as 1 over cosine. And when we're multiplying, we can cancel anything from the top with anything from the bottom. So this sine and this sine will give me a 1. This cosine and this cosine will give me a 1. And all of this is the same as just the cosine of theta. Okay? So, when are we going to use this, or why would we also do this? We're going to eventually get into solving equations now and using these identities. So, the first thing I would always recommend doing is getting rid of anything with a squared and a 1 in it. So, if you think back to our list here, this is what I mean. If you see anything with a squared and a 1, you want to bring that to something over here, where that we lose the 1. So 1 minus the sine squared of x is the exact same as cosine squared. And just like when we solved equations before, if you want to, drop the cosine for a second and see it like this. X squared plus x squared is 2x squared. Divide both sides by 2. 0 divided by 2 is 0. And take the square root of both sides. When is cosine of x equal to 0? Now we use our unit circle. Cosine is at half a pi, and also at cosine is 0 at half a pi and at 3 pi over 2. They are across from each other on the unit circle, so I can simplify it to just pi. Okay? So that's when we're going to put it all together. We're going to be using our trig identities to help us solve equations. So these would be probably 3 go-to things to help you. Number 1, rewrite in terms of sine or cosine if possible. 2, make all terms the same. So can everything be switched over into all sine, or all cosine, or even all tangents? And then this is the last thing I was just talking about. When you see an x squared with a +1 or a -1, can it be replaced with something on that list? Use these 3 rules to help you in the simplifying process and in the solving equation process.